Today we will be learning about the three trigonometric functions and the reciprocals and what are so important about them. So let's get right into it. Alrighty then, to start off, I would like to write down the three trigonometric functions that you need to know. So the first one is sine of theta, the second one is cosine of theta, and the third one is tan of theta. Now, where do you get these functions? So you'll see on the left here that we have a right triangle. And usually, other than the right triangle side, we usually put a theta on either the right side here or the top side here. So for simple purposes, we'll just put a theta here. So if that's our theta, where are we gonna, what names are we gonna assign the other sides of this triangle? So you see we have three sides. And the most important one, arguably, is the hypotenuse. Now, what is the hypotenuse? It's the sign that's opposite to the right angle symbol here. So this right here is your hypotenuse. Now, the next one would be the one that's opposite to your theta. So, opposite. You see here that there's two lines here that make up theta. There's this one and there's that one that make up your theta. But this line here, that's your opposite side. So we'll name that, just erase that. We'll name this one your opposite sine. Great. And the final one that leaves us with is the adjacent side, which is right next, bordering to the theta. So we'll name that the adjacent side. So let's get right into the trigonometric functions now. So as you can see, I've cleaned up the triangle a little bit, but starting off with sine of theta. Now sine of theta is basically the ratio, sorry about that. The sine of theta is basically the ratio between the opposite and the hypotenuse. So basically it's going to be opposite, whatever that value is, divide that by the hypotenuse. Cosine, on the other hand, is still going to involve hypotenuse, but this time we're going to do adjacent and the hypotenuse. So this one here will be adjacent over hypotenuse. That's not how you spell hypotenuse. One sec. Boom. Okay. And tangent can be two things. It can either be opposite over adjacent, so it's those two, not including the hypotenuse, or you can also say it's basically sine of theta divided by cosine of theta. Because if you were to take sine of theta and divide it by cosine of theta, the hypotenuses would cancel out, and you'd basically just have opposite over hypotenuse, which is the same thing as tangent of theta. Let me just clean this up here. So we're going to go on to the reciprocals of sine, cosine, and tangent. Now here you'll see I've edited some stuff. So I've cleaned it up a bit. I've made hypotenuse abbreviated as H, opposite as O, and adjacent as A, just to save some space. And you'll see that on top of adding sine, cosine, and tan, we now have the reciprocal functions of them, which is cosecant, secant, and cotangent. So just to review, sine of theta is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, or sine of theta divided by cosine of theta. Now, reciprocal means that you have two numbers, and when you multiply them, you get 1. And one of them is going to be 1 divided by the original number. So when we do 1 divided by sine of theta, we basically just flip the ratios. So now instead of opposite over hypotenuse, we now have hypotenuse over opposite. Instead of adjacent over hypotenuse, you now have hypotenuse over adjacent. Instead of having opposite over adjacent, you now have adjacent over opposite. Or for cotangent, instead of saying it's sine of theta divided by cosine of theta, it's now cosine of theta divided by sine of theta. And another way you can just write it is just simply 1 over sine of theta. This one equals 1 over cosine of theta. And this one here will equal 1 over cotangent of theta. Now, the question comes, what's so significant about these ratios? Well, these 6 trigonometric ratios you're going to use throughout the entire time you're learning trigonometry. They are the basics of the basics. You need to get them drilled down in your mind that sine of theta is opposite over hypotenuse. Secant of theta is a hypotenuse over adjacent. Cotangent of theta is adjacent over opposite. And there's some simple ways you can remember that. For sine, cosine, and tan, it's really just so, ka, toa. So the S obviously stands for sine, the C stands for cos, and the T stands for tangent. So let me just clean this up a bit. And the O parts of them. So for sine, you have O and H, which is opposite over hypotenuse. You have for cosine, you have A and H, which is adjacent and hypotenuse. And for tangent, you have O and A, which is opposite over adjacent. Now, for cosecant, secant, and cotangent, there's not really a clear-cut way for remembering them as we have with so, ka, toa. But one way we can use, if we were to write this out, cosecant of theta, and then secant of theta, and cot of theta. There's a reason why cosecant is written a little bit more expanded, is because if we were to look at the S here, right in the middle, that'll tell us that that's sine. That's sine right there. So then we'll relate that to the reciprocal of sine. For secant, you have the C right here. So then you can connect that as the reciprocal of cosine. And for tangent, you have cotangent. The T there can be connected as the reciprocal of tangent. And to finally end this video off, plus a few examples when practice problems we'll go through at the end. What do sine, cosine, and tangent really mean? Right? It's not like ancient mathematicians just gave these words to these trigonometric ratios. They have a meaning. So sine, when written out loud, is basically a word meaning curve. It comes from the word sinus, which is, I forget which language, but it basically means curve when translated into English. So sine is a curve, and when we go into sinusoidal functions, which we'll cover in later videos, we'll find why they're curved. Because in reality, these are not called trigonometric functions, they're called cyclic functions. And we'll soon go over why they're called cyclic and not, say, triangular functions. Cosine, when expanded, is, you see, they both have the word sine, but here you have this co. And the co has a meaning. It stands for complementary. Complementary. Now, what does it mean when something is complementary? Well, it basically means that this plus that equals 90 degrees. So, if you were to take the sine of theta and the cosine of 90 minus theta, they'd both be the same thing. Now, this is a certain type of trigonometric function, which we'll again cover later, but it's pretty neat stuff that sine and cosine are interrelated. The cosine of theta basically means a shift in 90 degrees of sine of theta, and you'll see that when we look at the sinusoidal waves of certain sine and cosine functions. Tangent. Tangent might remind you of something that touches once. Tangible means it's touchable. So if we have, say, a circle, and you have a line that touches just right there right at one point, that's a tangent. It's tangent to the circle. It only touches the circle, or basically anything for any matter, at only one point. Cosecant again has that word co, which is again complementary to secant. And cotangent is quite the same. It's complementary to tangent. And you'll see there's a kind of, how should I say, like a reciprocative symmetry here. Because you see in the three original functions, sine, cosine, and tangent, you have only one trigonometric function that has the complementary, while in the reciprocals, you have two of them. So there's also some of this naming convention and mathematical symmetry interrelated when you're trying to give them labels. So it's not like people just came up with random labels. No, it actually has some meaning behind them. For example, secant is basically a circle that intersects the circle, has a line that intersects the circle at 2 points. So they're a bit different, you know. Secant has 2 points, while tangent has only 1 point, 1 point connections. So it's all very cool stuff. You don't really need to know this for, say, a math class, but you know, the point of math is never to just memorize, it's to understand. So thank you for everything. Let's do a couple of practice problems so we can check comprehension. Alrighty then, you'll see on the screen that we have two practice problems, A and B. You can do them on your own time. The answers will be in the description, so you can go ahead and check those out. Once you've done them, you can comment your answers and see if you did learn something from today's lesson. Thank you.